Okay, so there are two plots that we want to draw for body plot. One is for gain, one is for phase, mg and phase. So let's scale this 0 0.01, 0 0.1, 1, 10, 100, and that should be enough. 0 0.01, 0 0.1, 1, 10, and 100. Okay, so first thing we can do is to figure out at s equal to 0, at the 0 frequency, what is g of s? At s equal to 0, the 0 frequency, g of 0, it's going to be equal to 1 over 0 0.1 times 10. It's going to be 1 over 1. It's going to be 1, right? So at s equal to 0, mg, it's going to be 20 log of 1, which is basically 0 dB, right? So we know that at s equal to 0, at s equal to 0, our gain starts from 0. How about the gain? How about the phase? Like a real number, its phase is 0, right? So the phase is also going to be 0. This is in terms of dB. This is in terms of degrees. So phi of g at s equal to 0, it's 0 degrees. As s goes to infinity, we can basically ignore all these numbers, right? So like, because s is going to be much bigger than 1, 0 0.1, and 10, so g of s basically is the same as 1 over s. Or like 1 over j omega, right? So in this case, when you have 1 over s, it means that mg, it's gonna be moving with the minus 2b per decade. For each pole, this is gonna be minus 20 dB per decade. And the phase, it's gonna be negative 90 degrees. So we know that this should be something that we have to expect as s goes to infinity. So we should be seeing like a line with the slope of negative 20 decibel per decade, and a phase of negative 90 degrees. Okay, so let's just like now look at the poles and zeros. So we have 0 at s equal to 1, and we have two poles, one here, one here. Okay, so something to keep in mind is that the effect of poles and zeros is that each pole would cause a negative 20 decibel per decade, and each zero would cause a positive 20 dB per decade, right? That's why, like, we knew that, like, at s equal to infinity, this is what we should expect. Okay, so doing the gain plot is very easy. So like up to here, We don't have any poles or zeros, so just like it's gonna stay at it's gonna stay at 0 decibel, right? And then here at 0.1 we have a pole, so like then it's gonna, in this decade we're gonna have a slope of negative 20 dB per decade. So at this frequency we get to negative 20. Okay. Now we have a 0, which is gonna add 20 dB per decade, which is gonna have an impact of 20 dB per decade. These two now are gonna cancel out, right? Because we were supposed to have a line going down with negative 20. Now we have another line going with positive 2B. They cancel out, so like then up to this point, the gain, it's gonna stay at negative 20 dB, right? And now we have another pole, so now we're gonna have our gain, it's gonna be negative 20 dB per decade from this point on, and it's gonna continue. Okay, so this was how you can draw the gain body plot. That's how it is done. It's not going to be exactly like this. This is just an approximation. If you draw it like it's not going to be exactly like this. It might just like look a little bit different, but it's a very good approximation. Now, doing this for the phase is a little bit more challenging. So like again, I'm going to show that the poles and zeros here. So the impact of pole and zero is basically like they have a minus 45 degrees per decade impact and a plus 45 degree per decade impact. But this starts from 1 decade before and lasts up to 1 decade after. Okay, so that's the challenging part. So we have a pole here, right? So up to 1 decade before this pole, there's nothing happening here. So the phase is gonna stay at 0 degrees. Okay, but now we have a pole at 0.1. So from 1 decade before this, we're gonna have a line that goes minus 45 degree per decade. So at this point, we're gonna get to minus 45 degrees. And it's gonna continue, right? So it wants to continue up to here. Okay. And then it would just like, it wouldn't have any impact after that. But at 1, we have a 0, right? So